Alright team, let's start a new robot project using the Godot engine and the BPlay add-on. We're going to follow the Getting Started tutorial in the docs at robogame.dev. At the end of this tutorial, you'll have a microcontroller connected to Godot, a blank canvas ready for you and your mad science. Step 1 is to select a microcontroller. This is the hardware that will interface with your servos and sensors. It makes them accessible to Godot over the network. BPlay can work on most recent CircuitPython devices and any single-board computer with Python, such as a Raspberry Pi. CircuitPython devices are ideal for small projects where a camera isn't required. You should choose one with an ESP32S2 or S3 and a good amount of PRAM. If you don't know what to use the same as me. I'm going to use an Unexpected Maker Feather S3 because it's got a lot of power and outputs, and its form factor fits with the excellent Adafruit Feather set of components. These cost about $20 each. Not bad for a robot controller. Step 2 is to create a new Godot project and install the BPlay add-on. Download Godot if you don't already have it. Then create a new project with the default settings. Now download the BPlay Godot repository and the BPlay repository from the RoboGame GitHub. Extract BPlay Godot into a folder called Add-ons inside your game project. And we're going to fix the name here because it's bringing in main from GitHub. Then extract BPlay inside the BPlay Godot folder inside of Python. And we'll fix the name there as well. Now, returning to the Godot editor, go to Project Settings, Plugins, and enable the plugin. It's normal to have errors at this stage, so we're going to relaunch the project twice. Re-enable the plugin, reload the project, and now we can see that it's all set up. There's no output. There's a new bot assets doc on the left-hand side, and we have a new bots doc on the right-hand side. We're ready to begin setting up the microcontroller. Get out your CircuitPython device and plug it into the computer. Our device is plugged in. We can see it in the bots panel. We're going to choose Update Runtime. It's going to begin copying the runtime to the bot. We're going to have to wait for it to finish copying, which happens a long time after the console prints, and then we'll be prompted to enter Wi-Fi information. The bot's now installed. If you're using Windows, don't forget to safely eject it, and we're going to unplug it and re-plug it back in. The bot's going to be joining the Wi-Fi network now, and we can begin scanning our local subnet to find it. So I'll give it another couple seconds, then head down here to the bottom of the bots dock and choose Scan Local Subnets. Found it. The bot's online, and we can tell because it's got its eyes open. We can now select the bot and choose Remember. This will store the bot's IP address in the project, so we can find it without scanning subnets in the future. Finally, let's make sure it all works. by enabling the link. Excellent. The device has turned green, which means that we've linked to it successfully. We now have a connection to the device live from the Godot editor, and we can move on to the other tutorials and begin adding parts and building robots with it.